Okay, good morning everyone. Thanks for coming. I'd like to take this opportunity to welcome you to a demonstration that will share some developments at Ocean Networks Canada in the technology around earthquake early warning. So while a comprehensive system of earthquake early warning is not yet in place, there is progress being made, and today we'd like to share some of that progress with you. So as Adrian mentioned, Ocean Networks Canada is a not-for-profit initiative of the University of Victoria. And we essentially are operating and maintaining the world's most advanced cabled ocean observatories, monitoring hundreds of sensors in real time, collecting and archiving that data. Now, the map behind me shows the sensors that are collecting data on monitoring the Earth's tectonic plates, and some of these are being used for earthquake early warning. As you know, BC is a highly active seismic region where thousands of earthquakes are occurring every year. While most of these earthquakes are not felt by humans, they are recorded by seismic instruments across the province. BC is also located on a subduction zone. Subduction zones are where many of these earthquakes take place, and this is where the largest of all earthquakes can occur. These are megathrust earthquakes. In this region, Ocean Networks Canada has sensors on the ocean floor at the Cascadia subduction zone, close to where these earthquakes can occur. Now, the last time that this type of earthquake occurred, we know from the accounts of Indigenous groups up and down the coast, as well as scientific research that tells us the last time BC experienced a megathrust earthquake was in the year 1700 on the morning of January 26th. We know that will happen again, we just don't know when, and now is the time to prepare. So what is earthquake early warning? Essentially, when an earthquake occurs, a massive amount of energy radiates from that rupture zone outwards from the epicenter in a radius. Now, this happens in the form of seismic waves. The first seismic waves are non-destructive, and they radiate from the epicenter very quickly. If you have sensitive enough instruments, you can detect these first seismic waves and analyze what kind of shaking will occur in the event of the ground shaking. These are followed by more destructive seismic waves, which are displayed in the red arc in this diagram. Now, once those first seismic waves reach the sensors on the ocean floor, you can use that data and transmit that data to sensors that are, or to computers that are land-based, that can analyze that information and tell you the earthquake's magnitude, the location, as well as estimates on the ground shaking that could occur in different regions across an area. It's Ocean Networks Canada's ability to put sensors on the ocean floor that allow us to give critical moments to those agencies that need it most, to take action before the shaking occurs on land. So, there are four major components when it comes to earthquake early warning. And the first is a dense network of seismic sensors, ideally located close to where the earthquakes occur. Next is a system that communicates rapidly between the sensors, computer systems, and the end users so that that information travels very quickly. The third is reliable and accurate mass notification tools to get the information out to as many people as possible, as quickly as possible. And perhaps most importantly, end user education, so that people understand what to do when the shaking or when the alarm sounds. As I mentioned, Ocean Networks Canada has sensors on the floor of the ocean floor near the Cascadia subduction zone. These sensors are connected through fiber optic cables to give real-time information on earthquake shaking to be used in earthquake early warning, as well as other science and research applications and public safety applications. While scientists cannot yet predict earthquakes, information about incoming earthquake shaking can deliver benefits, including some simple examples, such as surgeons stopping surgeries, automatically triggering bay doors at ambulance and fire halls to open, or perhaps to trigger trains to slow down and gas lines to shut off. And also, for people, including school children, to drop cover and hold on before the shaking stops. Even just a few seconds of warning can allow people time to take protective actions that can save lives, reduce damage, and injuries. So for our example scenario today, we take a typical type of earthquake off the Cascadia subduction zone. This is a 9.0 type of earthquake, so not something that happens all the time, but something that we need to be prepared for. This event is also more commonly known as the Big One. In this event, it takes about 40 seconds for those initial seismic waves to radiate from the epicenter of the earthquake and hit the sensors that Ocean Networks Canada has on the ocean floor. After this 40 seconds, these seismic waves trigger the sensors, and it takes about 2 more seconds for that data to travel to the computer systems on land, analyze the data, and then deliver information to the end users. In this case, this scenario is being giving an alert through an earthquake alarm developed by electrical engineering students at the University of Victoria. And this alarm will sound, it will actually deliver a warning, a test warning, approximately 20 seconds. And that represents the time it would take for that shaking to happen in the Victoria area. So essentially, we're going to demonstrate an earthquake by pressing the red earthquake button. So that will trigger an earthquake at the Cascadia subduction zone. Not actually, but it will simulate an earthquake happening at the Cascadia subduction zone. It will also initiate a timer, which you see in front of you, and this timer will indicate the time it takes for the initial earthquake rupture until that shaking would hit the Victoria area. You'll notice that also when I press the button, a video will start behind me, and that will illustrate the system of earthquake early warning at Ocean Networks Canada. And at 20 seconds, you'll hear an earthquake alarm on the right-hand side of the display there. Again, developed by University of Victoria students in the electrical engineering department, which will actually sound an alarm. And I'll warn you, it's quite a loud alarm. And this alarm is designed to give an audio and visual alert, as well as it can be linked to other devices to automatically trigger events to happen, or actions to happen. So the question is, are we ready for the next earthquake, and what can you do when seconds count? And I think in this demonstration, we'll be able to assess what benefits earthquake early warning can have for people. So are you ready for the earthquake to start? Three, two, one.
Off the southern coast of British Columbia, 2 tectonic plates are colliding at the Cascadia subduction zone. Subduction zones are where the largest of all earthquakes are known to occur. In this demonstration, we consider a magnitude 9 earthquake occurring off Vancouver Island. This earthquake would take about 40 seconds to reach Ocean Networks Canada's offshore sensors. The data from these sensors are relayed to the shore, where they are analyzed in real time to determine when major ground shaking will occur in different locations. In this example, a warning could be issued about 20 seconds before the start of major ground shaking in the Victoria area.
Earthquake event detected. Earthquake event detected.
Even with just a few seconds of warning, critical actions can take place to limit damage and save lives. Trains can be slowed, surgeries halted, and people can find a safe place to drop, cover, and hold on until the shaking stops. What will you do when seconds count?